In this section, we're going to go ahead and graph exponential functions. We'll do this initially the old-fashioned way, point by point, and then we'll jump over to Mathematica to see how to do this using technology. After we graphed a few functions, we're going to go ahead and observe some properties of these functions using the graphs. Let's go ahead and start with an example. We're going to go ahead and sketch the following. And we're also going to go ahead and sketch g of x is equal to 1 divided by 4 of raised to the x power. Again, we're going to do this by input values. So this is going to be our x value. Over here, we're going to have our 4x. And in this last row, we're going to have our 1 divided by 4x. We're going to put in a few different simple values, like a -2, -1, 0, 1, and 2. And then we're going to go ahead and evaluate each of these functions. 4 squared is equal to 16. 4 raised to the 1 is equal to 4. And 4 raised to the 0 is equal to 1. Continuing on, we have 4 raised to the -1 is equal to 1 divided by 4. And 4 raised to the -2 is equal to 1 divided by 16. Let's go ahead and evaluate the second function. 1/4 raised to the -2 is going to be equal to 4 raised to the 2, which is equal to 16. 1 divided by 4 raised to the -1 is equal to 4 raised to the 1, which is 4. 4 raised to the 0 power is equal to 1. 1 divided by 4 raised to the first power is 1 divided by 4. Then we have 1 divided by 4 raised to the second power is 1 divided by 16. Graphing these values out, we'll go ahead and look at 4 raised to the x first. When we have a -2, then the y value is very close. It's 1/6. When our x is equal to -1, our y value is not as close to 0. It's a little higher. It's 1/4. And when our x value is 0, our y value is 1. So when we plug in 1 to 4x, we'll get 4 out here. And then finally, when we get 2, we'll get 16 as our y value. So our function looks something like this. And we can see that as our x values grow, our y values grow very fast. And let's go ahead and graph the blue one now. Again, let's start at x is equal to -2. This is going to give us 16. When x is equal to -1, we get a 4 out. When x is equal to 0, we get 1 out. When x is equal to 1, we get a 4th. And when x is equal to 2, we're going to get 1 divided by 16. So again, this time our exponential function's growing in reverse. As our numbers become more negative, our y values increase extremely fast. Let's go ahead and see what kind of properties that we can obtain from the graph of this function. The first thing that we can note is f evaluated at 0 is always going to be equal to 1 for all defined a. The second thing we can notice is the domain of an exponential function is going to be all real numbers. The third thing that we notice is the range of our exponential functions is going to be all non-negative, non-zero numbers. The fourth thing that we can notice is that if our base a is going to be greater than 1, then the graph is increasing. And this is from left to right. And it also has the following shape. The next property is going to be the mirror image of this one. if we have that a is greater than 0, but less than 1, then the graph is going to be decreasing. Again, from left to right. And it also has the following shape. The next thing to note is that the line y is equal to 0 is a horizontal asymptote. Let's go on to another example. What we want to do is we want to find the equation of the given exponential function. And we're given the graph of this function. So the graph of this function looks something like this. And we're given one point on this function. It's given by the point -3, 8. To solve this problem, we need to use the point -3, 8 on the graph to come up with a relation. The thing that we do know is that if we evaluate this function at -3, this is going to be equal to 8. Because we're given that this is an exponential function, we know it's going to be of the following form: a raised to the -3. 8 is then going to be equal to a raised to the -3. We can then go ahead and write the right-hand side of this equation as the following. This is going to be 1 divided by a raised to the 3rd. This is still going to be equal to 8. So let me go ahead and rewrite what we have over here. So we have that 1 divided by a raised to the 3rd is going to be equal to 8. Taking the cube root of both sides, we're going to see that this is going to be 1 divided by a is equal to 8 raised to the 1/3. 8 raised to the 1/3 is equal to 2. We're left with a is equal to 2. Solving for a, we get that a is equal to 1 divided by 2. Our exponential function then is going to be given by y is equal to 1 divided by 2 raised to the x power. And this matches with what our graph is telling us.